So number 5. I'm going to rewrite that. X to the 4th minus pi to the, what power would that be?
Negative 1/3? It should be 1/3.
Yeah.
1/3, not negative.
Oh.
Where do the negative powers come in?
If it's on the bottom.
It's on the bottom. So I have something to the 1/3, so that's power rule. So 1/3 times the something to the 1/3 minus 1, negative 2/3. The something stays the same, right? You eat your blow pop one layer at a time, but you don't just take the wrapper off, you got to keep eating. So the derivative of x to the 4th minus pi, there's pi again, be 4x cubed, and the derivative of pi, what's the derivative of pi?
0.
0, because it's a constant. Free response, safe stop, you're good.
Don't you need to put on that negative pi though?
No. The derivative of x to the 4th minus pi is 4x cubed. Cleanup work. 4x cubed in the top. That 3 in the bottom. X to the 4th minus pi to the 2/3 in the bottom. If we're going multiple choice. Again, the test is about half and half, so that's why I usually give you both so that we get practice on our algebra, but we can also stop.
How do you write that in like the square root? Is it so that third and then?
Okay, so yeah, if you're looking, like you would never have to do that on your own, but if you're looking for multiple choice answers, let's see, the bottom number is the root. We all have Mr. Rainey where the root grows on the bottom and the flower power grows on top. Does that sound familiar? Maybe I said it. So the power is 2, the root is 3. So the cube root of x to the 4th minus pi squared. Yes, sir.
Does it matter if we put square root or we just leave the exponent, the 2/3 exponent?
So if it's up to you, you would stop right here and say, the heck with all of that, I'm done.
But
If it's multiple choice, I would probably be this one, but they could expect you to know that these are the same thing. Brett?
Where did the square root 2 over 3 come from?
Where did this cube root of 3 squared?
Like the second step.
This?
Yeah.
Power rule. Take the power down front. Reduce the power by 1. So 1/3 minus 1
Wouldn't that be? Oh, okay. Okay.
would be negative 2/3.
Okay.
There's 2 of these.
Question?
We're trying to figure out whether to use product rule or chain rule.
Okay. Product rule versus chain rule. So, definitely quotient rule, because I've got a top and a bottom. F prime, let's see, derivative of sine is cosine. Leave the inside stuff alone, that was only the wrapper. And then the derivative of 3x
Where's 3?
is 3. And usually we would put that in front because it would just look better. So I use the chain rule sort of as part of finding the derivative of f. Now, kind of back up, I'm still thinking about the quotient rule here. G prime, what's G prime going to be?
3.
3. That's kind of nice. So y prime is gf prime
3x plus 2.
times 3 cosine 3x minus fg prime
Sine 3x.
3 sine 3x all over g squared. And I don't know that there's much you could do with that anyway, so I would leave that alone. I guess you could distribute that 3 to those two things, but that's about it. Or factor out a 3, but minor stuff. So that one used the quotient rule, but it also used the chain rule. Other questions from the review? Let's see, second derivative, third derivative. On number 13, we know what a horizontal tangent line is.
0.
What's 0?
The slope is 0, which
Slope
means
is
the
0.
derivative is 0.
Means the derivative is 0. So y prime equals 1 plus 2, negative 2 sine x, since the derivative of cosine is negative sine. And we want to know where that is 0. So that would be 2 sine x equals 1, sine x equals 1/2. That's not a safe stop because you haven't solved for x yet. So you do kind of have to know the unit circle on that one. So what angle has a sine of 1/2?
Pi over 6.
Yep. Anywhere else?
5 pi over 6.
We got 2 a negative, so
And that's not a great question because you could also do negative 7 pi over 6 and negative 11 pi over 6, and you could add 2 pi to any of those. So it probably should have said on 0 to 2 pi to restrict our answers. Other questions?
Could that one have been written as a safe stop at inverse sine of 1/2?
It would have depended on how they asked the question, because inverse sine of 1/2 is pi over 6. So if they had said on 0 to 2 pi, you would have missed the 5 pi over 6 answer. So yes, but incomplete. Yeah, so I mean, hey, it gets you closer. If you can't, if you completely blank on the unit circle, you could write that and you'd get something. Other questions from the review? If you want me to tell you what's on the test.
sure.
This isn't, I don't know how helpful this will be, but so it's half-ish, so it's not, exactly 50-50, but I should have said part multiple choice, part free response. 2 questions about definition of derivative. One is straightforward, like number 1 on the review, where it just says use the limit process, use the definition to find a derivative. The other one is more like the one from the warm-up, where you didn't really use the definition, you recognized the definition, and then took a derivative. There's a couple questions about where is a graph not continuous, not differentiable. That's what we looked at on number 2 and number 3 on the review. So not continuous at holes, jumps, and asymptotes, not differentiable. Anywhere it's not continuous, it's not differentiable. There's a cusp, that's not differentiable. Several questions on find the equation of a tangent line, which is just another way of asking you to find a derivative. there's the rules that we know. Power rule, product rule, quotient rule, chain rule, and trig rules. And we'll be given equations, mostly equations. I don't know that there's any graphs on there. There's definitely tables. We didn't do worksheet 4. That's why there's not that much stuff on there from tables and graphs. There's a table question on the review though, so number 7 would kind of cover that idea. And then lastly, the idea of average versus instantaneous rate of change. Rate of change means slope, but average rate of change means algebra slope, good old algebra 1 stuff. Instantaneous rate of change means we're doing calculus, we're taking a derivative. So be careful about average versus instantaneous rate of change. AROC versus IROC. And then what's due, had 7 assignments, counting the review worksheet. I'm going to say that 6 of the 7 are due. So that you could also phrase that as the review can replace one of the assignments, or just 6 of the 7, however you want to think of it. Please make sure they're clearly labeled. If I don't have page numbers, it's really hard for me to keep up with what you're doing. So make sure your assignment is labeled.
So wait, what's for 125?
What's that?
What's for 125?
I didn't put numbers on that because it was the only page 125, so I wasn't really worried about it. It's on the calendar. Yeah, that was the one that was kind of lengthy. Great question. Why is this not product rule? It's because it's not cosine times 4x. It's cosine of 4x. So it's chain rule. The cosine is the outer part. So that would be negative sine of 4x, right? One thing at a time. And then the derivative of 4x is 4. And then clean that up a little bit. Negative 4 sine of 4x.